For a long time now, when you've been plotting points in the two-dimensional plane, you've been using the Cartesian coordinate system, a rectangular coordinate system. And it's worked out pretty well for you, but today we're going to expand our thought process on how we can plot points in planes. So with the Cartesian system, it was pretty simple. If you wanted to graph a point, 3, 5, the 3 tells you go 3 in the x direction, and then 5 in the y direction, and you've got your point. If you wanted to do, let's say, 0, 3. 0 means don't go left or right, and then 3 units up. Or we could do -6, 0. That means go 6 to the left, and then don't go up or down. Or lastly, maybe you want to graph a -2, -4. We would go 2 left, and then 1, 2, 3, 4 units down in the y direction. And so that's worked out well for us, and that was our building blocks as we started to learn about equations and how to draw graphs of equations. So instead of just plotting points, we got more sophisticated as we went year by year by year. But now I want to blow your minds with this new idea. Instead of this rectangular system, what if we had more of a circular system? So let's get rid of that grid, and let's think of two important pieces that we're going to need on our graph. We're going to need a pole, a point, which is kind of like, you could think of it as the origin, and then a polar axis, which is kind of like the positive x-axis. And as long as we have those two things identified in our plane, we can plot any point. So we have a point P here, for example. So now we need to give it coordinates, and so it's still going to have two coordinates, except they're not going to be x and y, they're going to be r and theta. So now you're asking, well, what's r and what's theta? Is that left, right, up, down? We're not doing left, right, up, down anymore. R is going to represent how far that point is from the pole. So that directed distance there is r. And then what about the second coordinate, theta? What does that represent? Well, theta is going to be the angle that OP makes with the polar axis in a counterclockwise direction. And we're used to doing counterclockwise angles from our unit circle. So we're going to have r and theta. And you can plot any point in the plane as long as you're starting with a pole and a polar axis. We can find that r value and we can find that angle theta. So let's try and plot a few points. Now, just like when you first learned how to plot points in the rectangular system, you had a nice grid. So instead of a grid, how about we have these concentric circles? And you can set your scale whatever you want it to be, but for example, any point on that circle, the r value is going to be what? Well, how far is it from the pole? 1 unit away. So whatever point you pick, it's going to have that r value. So r for radius, that's why they use the letter r. And likewise, we can move out to the second circle or the third or the fourth, etc. All right, so now I want to plot a point here, 4 and 120 degrees. Well, maybe I should label some angles. So that's going to be 0. And then 30 would be here. 45, these are the ones we're familiar with from the unit circle. 60, 90. And 120 is going to be over here. Now in this particular one, they have some other lines here. So this would be 15 degrees, and this one would be 75 degrees. So sometimes you'll see the polar graphs with just the 30, 45, 60, but sometimes you'll see the 15 and the 75 as well. All right, so what we want to think of is we want the r value is 4. So that means we want to be 4 units out from the pole. So if each of these circles is 1 unit, then our point is going to be somewhere on this circle. And then the angle tells us specifically where that's going to be. And so we're going to go to 120 degrees, and 4 units out is right there. And so we've got our point. Make an arrow over here for the next one. All right, so the next one, r is going to be 1. So we're going to be on this circle here somewhere. Our angle is 5 pi over 4. Where's 5 pi over 4 in radians? Well, that's why the unit circle was so important for us, because we want to be able to find that right away. There's your 5 pi over 4 angle. So let me label that 5 pi over 4. And the R value was 1, so we'd want to be right here. And we've got that point plotted. So once you get the hang of it, it's a pretty easy system to figure out. All right, what about the next one? R is 1/2. Okay, I get it. I mean, if we wanted, we could relabel these if it was a new graph, and we could call this 1/2, and then this would be 1, and that would, third one would be 1.5. But I'm just going to stick, because I'm putting them all in the same picture here. So half a unit is going to be halfway towards that first circle. But now the angle, that's the interesting part. 405. Wait a minute. 4 on 105, where is that? Well, if I keep going, oh, there's 360, and then I still need to go further. Oh, there's 405. It's coterminal with the 45-degree angle. We learned about coterminal angles way back. So, yeah, that's 45, but it's also 405. It's also, what, 765, and so on and so on. It's also negative, what's that? That's a negative 315 degrees, isn't it? We could think of, let me get my arrow back here. Whoop, not there. Let's take this arrow. Negative would be going this way, clockwise, right to there. That would be negative 315 degrees. So we have a lot of ways of representing this angle here. And that brings up a really interesting point when we're talking about polar coordinates. Wait a minute, do you mean to tell me that I could have written this as 1/2 comma 45 degrees? Why, yes. Oh, well, how about 1/2 comma, I'm a negative person, negative 315 degrees. How about that? Sure, that's fine as well. So let me plot the point first before I continue this discussion. So there's about 1/2, I had to eyeball that. So that's that third point there. But this brings up a super important idea that polar coordinates, we could have a point in a two-dimensional plane, and there's an infinite number of ways to write the polar coordinates for that. Now the next example, we'll get into that a little more deeply. But in the rectangular system, let me jump back there. In the rectangular system, there was only one way to represent a point. And once we had those coordinates, there's no other coordinates that represent that same point. Well, that's kind of nice in a way, but it's kind of nice in a way that maybe we can represent stuff multiple ways. All right, let's graph this last point, negative 1 pi over 6. So wait, we know pi over 6 is 30 degrees. Okay, so we got that. Let me write that pi over 6 next to there. Pi over 6 radians. But it's a negative 1 for the R value. So what do you think? Well, it's not going to be right there. That would be positive 1 pi over 6. So what most people would guess is negative 1 means we're going to go in the opposite direction. So we're going to go right there. Well, what's this angle here? Well, that's 7 pi over 6, isn't it? So we're going to go actually 1 that way. And that would be the point for negative 1 pi over 6, which we could also represent as positive 1, 7 pi over 6. Okay, so like I said, it takes a little while to wrap your brain around this because you're used to doing everything in the rectangular system, but the circular system works out very nicely too. And it's not very difficult to do, especially since you've already done a lot of trigonometry with the unit circle. All right, so let's talk about the different ways to represent points. So if P is a point with polar coordinates 2 pi over 3, well, first of all, where is that at? Well, pi over 3 is there, 60 degrees. And if my units are 1, I'll have it go out to the second circle here. So there's R equal 2, and the angle is pi over 3. This says find all polar coordinates for P. Let's label that with a P. There we go. Well, I mean, we could write it as 2 comma pi over 3, but another arrow over here. What if I wanted to go all the way around once? That's 2 pi, and then another pi over 3. What would that be? What's that? 7 pi over 3? So 2 comma 7 pi over 3. Well, what if I went around 2 times? then that would be another 2 pi, so that's 13 pi over 3. Well, how about, I don't like being positive, I'm going to be negative. I'm going to go this way. What would that angle be? That would be negative 5 pi over 3, wouldn't it? So I could also write this as 2 comma negative 5 pi over 3. And so on and so on. So I could just keep going around the circle. I could keep adding 2 pi's or subtracting 2 pi's, and I'm back at that same spot where the point P is. So I can't just keep writing these forever. My arm would get tired and I'd never finish. So how about we do this? How about we generalize and say 2 comma pi over 3 plus 2 pi n, where n represents any integer. So if n is 0, I have 2 comma pi over 3. If n is 1, I'd get 2 comma 7 pi over 3. If n was 2, I'd get 13 pi over 3. If n was a negative 1, I'd get 2 comma negative 5 pi over 3. So by filling in different integer values for n, I actually would be able to write down all the possible answers. So there's an infinite number of solutions, and we've taken care of all the possible solutions for our angles. But wait a minute. That's actually only half the answers. Wait a minute, how can half of infinity still be infinity? Well, that's if the 2 was a positive value. What if the angle we're dealing with is really here? And then the r value would be negative 2. So I could also have written this as negative 2 comma, and what would that be? That would be 4 pi over 3, wouldn't it? If I started over here at 0, and then all the way around to here, that's 4 pi over 3. So, but a negative 2 would send it in the opposite direction, and we'd get to the point P. And likewise, I could keep adding or subtracting multiples of 2 pi to that angle, so plus 2 pi n. And so now I've got all the possible ways that I can write that point P, all the different coordinates. So half of them are if you have a positive r of 2, and the other half is if I have r to be a negative 2. And notice pi over 3, and the angle down here, which I didn't write. Let me write that. Notice those are half a circle apart, or pi units apart. Okay, so there might be, you might see in some text different ways to write these. Sometimes I've seen this they get a common denominator and combine these, but I think writing it this way makes the most sense. All right, let's try one more example. I've plotted 3 different points here in the polar system, and I'd like you to not only write polar coordinates for each point, I want you to write 3 different polar coordinates for each point, and the angle needs to be between negative 2 pi and 2 pi. So let's tackle this. Actually, this might be a good place for you to hit pause, try it, and then hit play and see how you did. All right, so I'm going to do point A. So first thing I need to do is let's write the angle. And since the directions have theta between negative 2 pi and 2 pi, let's do this in radians. All right, so what is this angle here? Well, that's 30 degrees or pi over 6. All right, so, and if I have my circles with radius of 1 unit, that would be 1 and that would be 2. So this is going to be 2 comma pi over 6. So that's one way I can write. Let's do it in a different color. So A I can write as 2 comma pi over 6. All right, one done. Let's write it another way. Instead of 2 pi over 6. Well, I can't go all the way around the circle and then another pi over 6, because that takes me outside the constraints here. But what if I went in the negative direction, going this way? What's that angle? Negative 11 pi over 6. So I could write this as 2 comma negative 11 pi over 6. That's greater than negative 2 pi, so I'm still within the constraints. And then I still have to write this a third way. Well, I can't keep going around the circle there because I'll be outside my negative 2 pi to 2 pi. But I haven't used the negative r. So what if I think of this angle here and then r would be negative 2. So I could also write this as negative 2 comma, and what's that angle? That's 7 pi over 6. And now I've written it 3 different ways. Now you might be thinking, wait, couldn't I also write it negative 2 with a negative angle? Negative 5 pi over 6? Sure. So that's a 4th way I could have written it. But the direction said 3, so we're good. Although if you choose the negative 2 and the negative 5 pi over 6 in place of one of these, you're still correct. All right, let's do the next one. Let's do point B. The r value there is 1, so it's on that innermost circle. So r is 1, and then we need to figure out what's this angle here. Once again, I hope you hit pause and try these and then check your answers. So B is going to be 1 unit out, and then that angle is 5 pi over 4. And I should write that down here. 5 pi over 4. Get my arrow out of the way. All right, if I wanted to think of this in the negative direction instead of positive 5 pi over 4, if I started here and went this way, that would be what? Negative 3 pi over 4? So that would be another way to write it. So 1 comma negative 3 pi over 4. Or how about I think of this as a negative 1, and then my angle will be over here, which is going to be at pi over 4. So let me label that. So I could also write an answer as negative 1 comma pi over 4, which is, by the way, half a circle away from 5 pi over 4. Pi over 4 plus pi is 5 pi over 4. Or 5 pi over 4 minus pi would be pi over 4. And then I could also have written this as negative 1, negative 7 pi over 4. So that would be a different option if you didn't have that one. All right, let's do the last one. Point C. And the most straightforward way to look at that one would be if we start at 0 and we go counterclockwise, we all know that's 3 pi over 2. And the r value is 1, 2, 3, 4, 5. So let me write the angle here, 3 pi over 2. And so we've got r is equal to 5, and my angle is 3 pi over 2. Or if I went negative direction, then it would be 5 comma what? Negative pi over 2. And if we decided that we wanted this to be a negative r, then our angle that we're dealing with would be up here, which we all know is 17 pi over 87. Just making sure you're on your game here. Pi over 2. You could also think of it as negative 3 pi over 2, but I'll use positive pi over 2. And the r value then would be a negative 5 at pi over 2. And there you go. 3 different ways to represent them. So hopefully now you have a good feel for points in a plane using the polar coordinate system. And practicing is the only way that you'll get better at it.